Hi everyone, welcome to the channel. This is Fahad Mirza, and in this video I am going to show you a very interesting model called as Watermark Anything. We are going to not only learn about the architecture of this model, but I will also be showing you how you can play with this model in free Google Colab. I will also be sharing the link to that collab, so don't worry about copy pasting the code. The thing is that all of these image watermarking methods, which we also have seen with AI on our channel, are not really custom to handle small watermarked areas. This really limits application in real world scenarios where parts of the image may come from different sources or have been heavily edited. This is where this watermark anything or WAM model helps. The WAM embedder modifies the input image while the extractor segments the received image into a watermarked and non-watermarked areas and recovers one or several hidden messages from the areas found to be watermarked. With this simple technique, the model is jointly trained at low resolution and without perceptual constraints than post-trained for imperceptibility and multiple watermarks. They have also shared a lot of benchmarking information and how they have trained it in the paper, which you can find from this GitHub repo by going to this archive, and I will drop the link to it in video's description so that you can also play around with it. Now let me take you to my Google Colab, which you can also access at colab.google.com, and we will play with this model after downloading. Before I do that, let me give a huge shout out to AgentQL who are sponsoring this video. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page, it is resilient, it is reusable, and it structures the output according to the shape of your query, so please do check them out. Okay, so this is my Google Colab. First thing, go to runtime, change runtime type to T4 GPU. You can run it on CPU, but this is free GPU, so why not take advantage of it. First step, we need to git clone the repo, and as I said, I will drop the link to it in video's description. It is simply git clone command. Shouldn't take too long, it's not a huge repo, so let's wait for it to get downloaded, and that is done. Next step, let's download the models from this directory and then install all the requirements from this repo. This is going to take few minutes, so let's wait, and you can see that the model is not that huge. And then it is asking me to restart the session, which I have done. That is fine, no problem, but it has downloaded the model already and we have restarted it. And then let's cd to that watermark anything. In this Google Colab, we have seeded into it. Now as a next step, we need to specify some of the models parameter. We need to load the model onto the GPU, and the commands are very familiar if you have been watching my channel. All we are doing it, we are importing this OS library, then we are importing NumPy and Pillow, then Torch, and then we are loading the model. And then if we have GPU, it is going to use GPU, otherwise it is going to use the GPU. And this is a simple function to load the images where we will be testing it out later on. And then I am asking it to load the model, so let me run it. And as this is a very small model, so it didn't take too long to run. Next up, let's also specify a random seed value to initialize it. This is our image directory. You can specify your own, and then I'm just specifying that 2 images. This is where we want to do the watermark from this folder, and then we are just giving it the proportion. So 0.5 means 50% of it, and then this is the output directory, and OS is making directory if it doesn't exist. So let's run. That is done. And now let's do the inference. For the inference, let me first paste the code and let me explain it to you what is happening. It's very simple code, by the way. All we are doing it, we are defining a 32-bit messages to be embedded, just converting that into numerical representation. We are iterating over the images we have given it to, and then First, we are loading the and pre-processing the images. Then we are embedding the watermark message into the images, whatever we have done here. And then we are creating a mask just like we do in segmentation of the image. And from where we are detecting the watermark with the help of this segment function. This is related particular to their model. And then this is where prediction is made by the model. And then this is where the image is being saved, and then it is also plotting it, and it is going to show us in the colab. So let's run it. And you can see that it was very fast. So this was the original, sorry, let me go up. This was the original image, and then a localized watermark you can see was done. This is the original and localized image. How good is that? And then this is a position of watermark which it has detected, and then predicted watermark position. And then there is another example of the second image because we set it 2 images. There you go. Again the difference, how good is that? And then this is the one predicted message for the image alpaca. It has also shown you the what sort of accuracy it has done. Amazing stuff. Another cool thing about this model is that you can even do the segmentation. So let me put the code here, and it's a very typical segmentation code where we are importing the library, we are giving it samples, and then there is some matrix multiplication is happening. You don't really have to understand the whole code here if you are not interested in the nitty-gritty. All you need to do is to place your images in assets and then run this code. It is going to detect the watermark, and then it is going to give you the inference here. And look at the speed of it. This is the original image, this is the image with localized watermark, and then this is the difference. How good is that? It has segmented it, and there you go. There is also position and predicted watermark position, and then it has also told you the accuracy. As I said, I will drop the link to it in video's description, but I'm very impressed by the speed and the accuracy of this Watermark Anything model. Let me know your thoughts, especially around the speed of it, because we already have covered models like Segment Anything, which is one of the best models out there, and this one has really done it quite well. Also, if you're interested in this paper, read through this. This is really good. Not only it is very nicely written, but there are a lot of nuggets which you can select, lot of examples around watermarking, and then there are also discussion of some of the parameters which you can tinker with if you're not getting the desired results. So that's it. Let me know what do you think about it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.